Okay, this video does cover some significant ideas for electron configurations on the periodic table. We'll review first what we know and then move on to D and F orbitals. All right, so let's get started. We know already about the s orbital. There is one location in space for an s orbital. So if I put one dot in an s orbital, that represents an arrow up. If I put another dot, that represents an arrow down. So there's our S2. There are three spaces available for p orbitals in the XYZ system, so there's three lines for those. I can put one dot in each one of these. That, of course, represents a P3, arrow up, and then arrow up. And when I put another dot in each one of these, that gives us our pairing of arrow downs. Okay, so then this is our P6. And of course, we can put those dots anywhere we want to inside those, representing electrons in those orbitals. Now, what about the d orbitals? Well, we haven't studied those yet, but this is the pattern for our d orbitals. They look really different. But there are 5 locations in space for a d orbital. Each line represents a possible space for d orbitals. So since there are 5, there's 10 total electrons that can be there. So let me put 1 in each of these. And again, I can put them wherever I want to. There are no boundaries to the shapes anyways. So this represents 1 electron in each one, so that's our D5. And then if I pair more in there, again, it doesn't matter where I put them, this is our arrows down. So there we go. And this is our D10. So very different. And then finally, there are f orbitals, and you're going to see there are 7 locations in space for f orbitals. So I'm drawing 7 lines, and I could put 1 in any of these guys at any given time. And that represents an arrow up for each one. This, of course, is our F7. Now, if I go and put more electrons in these, add 1 electron to each one, these will represent our pairs, or arrows down. So this represents our F14. So 14 total electrons can be in an F system. So there we go. And we see that each time it gets more and more complex, we get 2 more orbitals each time. So there's 1, there's 3, 5, and then finally 7. For a total of 2, 6, 10, and 14 electrons. Of course, there is a connection to all these in the periodic table. Let's review what we did before. We said all of these groups here, this is all S1s, these are S2s. So this is known as the S block. We've skipped all of these before. This is P1, P2, P3, P4, P5, P6, remembering that helium, of course, is our exception, S2. So this is known as the P block. Well, there are 10 elements, 10 element rows here between these two, and these are where the D's are nestled. So this is the D1 column, D2, D3, D4, D5, all the way up to D10. But what's different about the D's is these are transition metals. So they are once out of order. You notice that we're in the 4th row, but this is 3D1, and then 3D2, 3D3, all the way through 3D10. And this, of course, is 4D1, 5D1, 6D1. So we know that the D's are once out of order. That's why they're called transition metals. So this is D1 all the way through D10. Okay, now what about the bottom 2 rows here? Well, the bottom 2 rows are where the f orbitals are, from F1 all the way through F14. But these are twice out of order. So this one's 4F1, and this is 5F1. This is 4F2, 5F2, etc., all the way through. Now, if you look carefully at the order of the periodic table, after you come to this element here, so in other words, we're going through the periodic table all the way through, we actually hit this element, and then we go down here. We're going to go through all of these, and then back up to here, and then continue. When we reach this element, we go down here, and then all the way through, and then back up to here. Okay, so these are the f orbitals down here, but they do go twice out of order. So instead of a 5, we're a 4. But this row should be all 6s, but we're twice out of order. So it's best to practice in order to get a really good understanding of what we're doing here with these orbitals. So let's go back to the periodic table, and we'll try some examples here today. Let's look at chlorine, for instance. Okay, chlorine is in the P5 location. So if we go back here, chlorine is right here, P5 location. It's in the 3P5 location. So we remember that if I write a P5, okay, I also have to write a 3S, 2. Okay, then I go up, and I have neon as my noble gas. So I'll put brackets around that. So this is neon, 3s2, 3p5. Now, of course, I can do the electron dot pattern for this. So it's arrows up, arrow down. Okay, and then arrow up, and arrow up. That's only 3 electrons, so I got to pair 2 of them, and 1 left by itself. So chlorine will have an electron dot diagram of 3 pairs, and then 1 by itself. So far, so good. And that's just a review of what we've been doing already with our S's and P's. Let's pick a couple elements inside the d orbitals. So here's iron, Fe. Okay, so this one here is in a D situation. Okay, and I'm going to count over. This is 1, 2, 3, 4, 5, 6. This block here is the D. So I'm in the 6th one over. So I know I'm going to have a D6 here. So I write D6. Now I must have a S2 immediately. Okay, just like in the P's, if I'm in the d orbitals, I gotta have an S2. So what would it be? Well, this happens to be a 3d6, and then we're in the 4th row, 4s2. So we notice we're in the 4th row, but remember, these are 1 lower, okay, than the S level. And let me get my noble gas. This is argon, Ar. So it's argon, 4s2, and a 3d6. Now I need 5 lines, 1, 2, 3, 4, 5, trying to squeeze that in there. And on these 5 lines, I need to put 6 electrons. So then I'll go arrow up, and then I'll continue doing arrow up. I've got 5 of them placed. I need to go 1 arrow down to get my 6. Remember, keep them separated. And so I've got 5 lines, I'll keep them separated. I've got a 3d6 there. So that's the noble gas configuration for iron. Now, what about the dot diagram? Well, I'll draw Fe. They might be thinking, wow, there's going to be a bunch of dots there. No, only the outermost level counts. The 3 is underneath the 4. So only the 4 counts, and there's only 2 electrons there. So Fe with 2 dots. These 3D will not appear in the S. So you're going to notice that the bulk of the atoms in this middle of the periodic table and down here, they're all going to have 2 dots. There are a couple of exceptions that will have 1 dot, but we will cover that when we look at the periodic table as a whole. We've done a lot with the periodic table, but there's some other concepts that we want to cover. Okay, so let's take a look, continuing. Let's do niobium, Nb here. Okay, so niobium, I'll write that right here, Nb. Okay, this one happens to be a D3, so I'm going to write a D3 here. And I'll immediately write an S2. If I've got a D3, I must have an S2. All right, let's see what we got. Well, we're a 5s2, and therefore we should be a 4d3. Remember, the d orbitals will be one set of order. So here it goes. I'm going to have an arrow up, down, and then 5, 1, 2, 3, 4, 5 with 3 arrows in it. So arrow up, arrow up, arrow up. And let's get the noble gas for niobium. Go up and over. It looks like that'll be krypton. So there we go. All right, now, once again, the 5s2 is over the 4d3, so the 4d3 doesn't count, only the 5s2 counts, so 2 dots only. So that's how we handle the d ones. All right, now what about when we go down here into the F? So we look at the order. So the order would go barium, and then you'd go lanthanide, and then you go all the way through here and then back up again if you look at the numbers. And then we go here, radium, and then we go actinium down here, and then go all the way through these guys, and then back up to here, and go all the way to here. That's why I had you do these arrows here. That's the order of the periodic table. Okay, so hopefully that makes good sense. But if you look at the atomic numbers, they increase going here. There's a big gap here between these two. Why? Because you got to go down here all the way across, then come back to here, and then keep going. And once you reach here again, you go down here all the way up, and then you come back here and then complete. Let's pick samarium here so that you get a good example of how to do this. So SM, that's in the 1, 2, 3, 4, 5, so that is an F5. And what F5 is it? Well, if we look at our table here again, that would be a 4. We're in the F5, only a 4. Okay, so that's a 4F5. Now we have to go backwards. So going here, back up. This box here, that's a 5D1. And then we got to go over and catch a 6S2. Okay, so how did I do that? Here's a 5F4. I got to go back this way to catch this guy right here. Okay, and then I got to go back one more to catch the 6S2. Okay, so hopefully that makes pretty good sense. And now I have to go up and over, and it looks to me like xenon is our noble gas. Okay, because remember we're going backwards from here to there. I got to go up and over and get the noble gas. All right, let's see if we can put the electrons on this. So 6S2 would be an arrow up and arrow down. I need 5 for the D, so 1, 2, 3, 4, 5. I only got to put 1 arrow there. Now I need 7 for the F. I'm going to be stretching that out over here. So 1, 2, 3, 4, 5, 6, 7. Okay, and let's see, 1, 2, 3, 4, 5. So starting here, it's kind of confusing, but let's draw, of course, 5 arrows on that. So that would be the noble gas configuration for samarium here. All right, now I'm going to put SM. We do need the dot diagram. Again, 6 is greater than 5, which is greater than 4, so only the 6S2 count. So we're going to put 2 dots there for the 6S2. Okay, and that's how we handle the periodic table with the F's and the D's. More will be talked about tomorrow in class on this, and I'll probably make another video to help you understand. Okay, that is it for now.